The final exam will be in two parts. You'll take the part 1 first, which is the calculator part. You want to make sure your calculator is in degrees pretty much for the whole thing. And then the second part is the non-calculator section. So the first part, I'll call it part 1, calculator section. And I'll post this on my website later tonight. So part 1 of the calculator section, question 1, it says, we have angle A is 68.2 degrees. Side B is 26.1 and side C is 57.8. Solve the triangle. Now, if you look at the final exam review that I gave you, the last page of that should be the formula sheet. It's the same formula sheet that you got for exam 4. That's what you could expect on the final exam. So you're going to have law of cosines, and you're also going to have law of sines given to you on the final. So first thing that we always do is we draw this just to get an idea of what we're looking to find. We might be able to get away without using law of cosines, but if we can't do law of sines, then we have to do law of cosines. So if angle A is 68.2, I'm going to label that. Side B is 26.1. Side C is 57.8. It doesn't look like we can make a full fraction of law of sines. So because we can't go right into law of sines, we could use law of cosines. And if we could figure out what side A is, we have angle A. So using law of cosines, we can get side A, make a full fraction with law of sines, and then finish it. So using law of cosines, A squared is equal to B squared plus C squared minus 2 BC cosine of A. This formula is given to you on the final exam. Let's plug in our numbers and make sure we could type it in correctly. B is 26.1, C is 57.8, or actually, yep, 57.8 minus 2 times 26.1 and 57.8, and then the cosine of 68.2 degrees. Let's make sure our calculator is in degree mode, and we're going to type it in exactly like this. We could just put the whole thing in all at once. So 26.1 squared plus 57.8 squared minus 2 times 26.1 times 57.8 times the cosine of 68.2. My calculator is telling me this is 2901.57. But remember, we don't round until the very last step. So what we're going to do is we're going to take the square root of the previous answer. The way that you do this on the calculator I encourage you to get is you just hit second x squared. So it says square root. And then you hit the second negative button, and it should tell you 53.9. And that's what side A is, 53.9. Now we have a full fraction that we could finish the law of sines with. So we'll have 53.9 over the sine of 68.2. And we could either solve for angle B, or we could solve for angle C. Doesn't matter. Remember, we could always check our answer to make sure that the largest side is opposite the largest angle and the smallest side is opposite the smallest angle. What I'm going to do is I'm just going to go ahead and solve for angle B here by cross multiplying. So 53.9 times the sine of B is equal to 26.1 times the sine of 68.2. And then if we divide by 53.9, we get sine of b is equal to, it's going to be a really ugly decimal. So you want to make sure that you could type this in. 26.1 times the sine of 68.2, close the parentheses, divide by 53.9, and I'm getting 0.4496. And we don't want to round. So what you do on your calculator is you hit the inverse sine button. And then second negative. So second sine and then second negative takes the inverse sine of this answer, and we get 26.7 degrees. And then we have one other angle to find. We could just do 180 minus 26.7 and 68.2. And I'm getting 85.1. Just a quick check. The smallest angle should be opposite the smallest side. Largest angle should be opposite the largest side. So everything checks out here. Second question, it says, from the top of a cliff 140 feet high, Josh sees a lighthouse. "72 feet offshore," or let's say 72 feet offshore. Find the angle of depression to the base of the lighthouse. All right, so if we're gonna set this up, let's draw a cliff. Josh is here, it's 140 feet high, and he sees a lighthouse. The lighthouse is 72 feet offshore. And we want to find the angle of depression to the base of that lighthouse. The way we talked about angle of depressions working is that you have to draw a straight line. And then the angle of depression is the angle that goes straight down from that straight line. So we're looking for this angle right here. Angle of elevation would be the angle that goes straight out and then up. One thing that we learn in geometry is called alternate interior angles. So if that's the angle of depression, that's the same angle as this right here. So you don't want to solve for the wrong angle. And then from here, we know the opposite side and we know the adjacent side. So if we were to take the tangent of this angle, we could write that as 140 divided by 72. We don't want to have tangent of the angle, we just want the angle. So to get rid of tangent, you could take the inverse tangent of both sides. making sure your calculator's in degree mode. Let's see what this angle of depression is. Second tan of 140 divided by 72 gives us 62.8 degrees. Okay, and then the last problem on the calculator section says let's do 2. Let me see. I'll come up with a good one here. Let's do 3 times the secant squared theta minus 11 secant theta plus 6 is equal to 0. Remember, we always want to make these kind of equations set equal to 0. That's a good way to get started. And the directions will ask you to solve this from 0 to 2 pi. All this means is that you don't have to add the period. So don't add the period. Well, for a problem like this, the way we talked about doing it in class is we can make a substitution. So this is an easier to factor trinomial. Instead of secant, we could just put y. So this just turns into 3y squared minus 11y plus 6 is equal to 0. That's a little bit easier to work with. And then from here, we have to talk about how to factor. What we could do is multiply 6 times 3 to get 18, and it has to add up to be negative 11. So we talked about factoring a lot in this class. We could use negative 9 and negative 2. And factoring, we'd get 3y squared minus 9y minus 2y plus 6 is equal to 0. We can cut it down the middle and take out a 3y. We're left with y minus 3. Take out a negative 2, y minus 3. And in factored form, we get y minus 3 times 3y minus 2 is equal to 0. All right, and then you just make these equal to 0. Y would be 3. 3y minus 2 is 0. So if you bring the 2 over, divide by 3, y is 2/3. And remember, y was just secant. So this is what we're left with. And our brains don't usually work with secant, so let's just convert these to cosine. The way we convert to cosine is we could take the reciprocal. This would be 1/3. This would be the cosine of 3/2. And then we have to figure out what angle gives us these. So this is where we talked about all students take calculus. And if all students take calculus, cosine would be positive in quadrant 1 and in quadrant 4. Similarly, with 3/2, that's a positive angle. So we're not going to draw it in quadrants 2 or 3. We'll draw it here or here. I remember the special triangles. In our special triangles, we can't get 1/3. We can get 1/√3, but we can't get 3. So you could always just take out your calculator and type in inverse cosine of 1 divided by 3, making sure you're in degree mode. And my calculator is telling me it's 70.5. And that's the reference angle that the calculator tells you. Technically, that's called the arc cosine. We talked a little bit about that. So 70.5 is the reference angle. As far as what these angles are, first angle is 70.5. That would be the answer. And the second angle would almost be a full circle, but we're short 360 degrees. So we're going to do 360 minus the 70.5. And 360 minus 70.5 gives us 289.5. Those are the answers that we'd get from one angle gives us a cosine of 1/3. You could always take inverse cosine if you don't think that you can use a special triangle for that. Now for the cosine of 3/2, that doesn't look like any kind of special triangle I've seen also. And plus, I remember for cosine, the graph just goes between 1 and -1. So the graph is never going to be 1.5. But even if you're not sure about that, you could always type into your calculator inverse cosine 3 divided by 2, and it'll give you an error. This is just no solution. So the only two answers come from that first factor, and that's 70.5 and 289.5. And that concludes the calculator section. So let's put our calculators off to the side so we're not tempted to use them. And we'll go through the non-calculator section. So this is part 2, non-calculator. And the first problem in the non-calculator section says f of x is equal to 2 times the sine of 6 theta minus pi over 2. And it'll ask you a few of the things we talked about when we're graphing. Before we even start anything, we should factor out this 6. So this just turns into 2 times the sine of 6 theta minus pi over 12. So this is 1/2 divided by 6 is the same thing as 1/2 times 1/6, which is 1/12. Does that make sense? Question was, where does the 1/12 come from? And you're doing pi over 2 divided by 6, which is pi over 2 times 1/6. So now that we're at this point, part A would ask you what the amplitude is. The amplitude would just be the absolute value of 2 or 2. The period, we're going to take the normal period of sine, which was 360 degrees, and we're going to divide that by the number in front of theta, which was 6. What do you think 360 divided by 6 is? It's 36 divided by 6. 60, right? So the normal period is The period for this graph is 60 degrees. The next thing it's going to ask you to do is it's going to ask you for the starting point of the first cycle. CYC LE. And it'll ask you for the end point of the first cycle. And then it'll ask you to sketch the graph. So we talked about doing this in class. So let's figure this out together. When we go to graph this, we said what we do is we take the period and we always divide it by 4. So you could do 60 divided by 4. You could do like long division if you want. What's 60 divided by 2? 30. And what's 30 divided by 2? 15. All right, so what we're going to do is we're going to start at the phase shift, and then we're going to have 1, 2, 3, 4 more points. This is how we went over doing this in class. The phase shift looks like it goes to the right, pi over 12, which, by the way, what's pi over 6? 180 divided by 6 is 30. What's 30 divided by 2? 15. So this is really 15 degrees to the right. So the start phase shift is going to be 15 degrees right here. For each point after that, we're going to add 15 degrees to that. So the next point's 15 plus 15. The next point is 30 plus 15. The next point is 45 plus 15. And then the next point is 60 plus 15. So you can see we're doing a full period. If we're starting at 15 and we're adding a full period of 60 to it, that covers a full cycle. So we're going to have 15, 30, 45, 60, and 75. And remember what the graph of sine looks like. The graph of sine looked like this. Starts off looking like an S for sine, and then it kind of goes down and back up. So we have 4 points we could use. First point is 0. This point is y value of 1, then 0, then -1, and then back to 0. So when we're sketching the graph, we're going to use those y values in order to sketch the graph.
It's 2 sine, but 2, not 1.
It does. Right, very good. Thank you. So if the original graph goes 0, 1, 0, -1, 0, then because this is 2 sine, the amplitude is 2. Thank you, Jared. So usually it starts at 0, so we're going to put 0 right there. The next point is going to be 1. So multiply that by 2. We get 2. 30, it's going to be 0. 45, it's going to be -2. Oh, wait, hold on. 15. Hold on one second. I didn't include the phase shift. So the phase shift is at 15 degrees at 0. Then it goes 30 is 2, 45 is 0, 60 is -2, and then 75, it's back to 0. So the graph would look something like this. Because remember, it got shifted 15 degrees to the right. And that's how you would graph this. We had plenty of practice problems in the supplemental materials folder. So if you're a little rusty with this, you can always go back to the notes. This was sections like 6.3 to 6.8. So if you want to review the notes or look at the supplemental materials, you could look at the stuff in those sections. All right, the next problem. Yeah, so the start point would be 15 degrees, comma 0. The end point would be 75, comma 0. All right, the second problem. It'll ask you to find the exact value of cosine of 2 theta if tangent of theta is 2/7 and theta is between pi and 3 pi over 2. So there's a couple different things we have to do to get started. First thing is pi is how many degrees? 180, right? So this is 180. And we've seen 3 pi over 2 before. Pi over 2, if you remember, is 90 degrees. 90 times 3 is 270. So this is just telling you to draw a triangle in quadrant 3. So you're going to draw a triangle between 180 and 270. It says tangent is 2/7, which makes sense because all students take calculus, and 2/7 would give you a positive tangent because both of those would have to be negative. To finish it, it's asking us for the cosine of 2 theta. There's 3 different formulas we have for this, so this is on your formula sheet. I'm just going to look at the first formula that catches my eye here, and it says cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. So in order to find cosine or sine, we have to figure out the hypotenuse. To get the hypotenuse, we'll do Pythagorean theorem. -2 squared plus -7 squared equals our hypotenuse squared. 4 plus 49 is 53. And then taking the square root here, you get the hypotenuse is the square root of 53. So when we go to enter these into our formula, cosine would be adjacent over hypotenuse. Sine would be opposite over hypotenuse. So 49 over 53 minus 4 over 53 is 45 over 53. This next section is a little tricky without a calculator, so I just wanted to review a couple things with you. Remember, we talked about pi, and we know that pi is 180 degrees. So there's a few other angles that you should be able to do like pretty quickly. You should be able to do 2 pi, which is 2 times 180 is 360. You should be able to do pi divided by 2. 180 divided by 2 is 90. You should be able to do pi divided by 3. 180 or 18 divided by 3 is 6, right? So this would be 60. Pi over 4. We've seen that a few times. 180 degrees divided by 4 is 45 degrees. And then we had pi over 6. Pi over 6, or 180 divided by 6, is 30 degrees. So those are things that you should, when you get your exam, you might want to write at the top. And if we know those, we could do everything else without a calculator. So I have 8 problems that we could work on here. Let me just double check something here. Maybe what I'll do is I'll give you 6 just in the interest of time here. So first problem is going to ask you to find the sine of 4 pi over 3. Second problem is going to ask you to find the secant of 3 pi over 4. Third problem is going to ask you to find the tangent of 19 pi over 6. Fourth problem will find the cotangent of 7 pi over 4. Then we'll find the cosine of negative 495. And lastly, we'll figure out the tangent of the inverse cosine of 2/3. And let's make the 2/3 negative. Okay. So what we'll do is we'll figure all of these out. First thing I would recommend that you do, remember, we're not allowed to use a calculator. So let's kind of resist that urge to do that. Let's set these up by drawing a coordinate plane. Another thing I just want to remind you about is we talked about coterminal angles. Coterminal angles mean if you add or subtract 360 degrees, you get the same exact answer. You just don't have to work with a really, really big number. So let's start with A. What is pi over 3? 60. What's 60 times 4? 240. 240 puts us right here. That's 240, and our reference angle is 60 degrees. From here, remember, anytime you go left or down, that side is negative. You just have to have these sides memorized by now. Opposite the 30 is 1, hypotenuse is 2, the 60 is √3. So this is an easy problem, as long as you have your special triangles memorized. Sine would be the opposite over hypotenuse. Easy, as long as you understand what the rules are. Take a look at letter B. What's pi over 4? 45 times 3. Well, 45 times 2 is 90. 90 plus 45 is 135. So 135 puts us over here with a reference angle of 45 degrees. So we have 1 and √2. Anytime we go left or down, it's negative. And I remember secant is kind of like cosine. Cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. let's kind of ease into the next problem. 19 pi over 6 is a huge number. So let's start with 7 pi over 4. A couple different ways we can handle this. One thing we could do is we could add or subtract 360, which is the same thing as adding or subtracting 2 pi. So we have 7 pi over 4. If you want to use a coterminal angle, we could take 7 pi over 4 and subtract 8 pi over 4. That's the same thing as 2 pi radians, or 360 degrees. We're using a coterminal angle. So that's 2 pi coterminal. 7 pi minus 8 pi is just negative 1 pi over 4, or negative 45 degrees. 1, 1, and root 2. Cotangent would be adjacent over opposite, or negative 1. If you don't like that, because we're working in radians, and maybe, if that was a little hard to follow, you don't have to do it like that. We could just do 7 times 45, kind of do it old school off on the side here. 7 times 5 is 35. 7 times 4 is 28, plus 3 is 31. So 315. 315 gives us a reference angle of 45 degrees. You'd wind up with exactly the same answer, but without a calculator, you could always do it like that too. Now, 19 pi over 6 is a really, really big number. What I would probably do is I would subtract 2 pi. So I would subtract 12 pi over 6 using coterminal angles. 19 minus 12 is 7 pi over 6. And then 30 times 7 is just 210. This is 210 degrees, which gives us a reference angle of 30. So we have negative 1, 2, and root 3. Tangent is opposite over adjacent, which you can't have a radical in the denominator, or just negative root 3 over 3. So I'm kind of going from radians to degrees and back and forth. If that's a little confusing for you, not a big deal. What you could always do is, we know pi over 6 is how many? Pi over 6 is 30, right? So we'll just do 19 times 30. You could just do it off on the side. No shame in doing it like that. Multiply by 0. 3 times 9 is 27. 3 plus 2 is 5. So we get 570. 570 is still a really big number. So we could just subtract that by 360 and we still get 210. That's the same angle we got before. You'd get the same answer either way. You could do it using, regular multiplication, or you could do it using a combination of radians and degrees.
Where do you come up with the 12 pi to subtract?
So do you agree that 360 is the same as 2 pi? All right, because what we're doing here is we're really just doing 19 over 6 minus 2. I mean, the pi's just kind of go along for the ride. Do you agree with that? Now, when we combine fractions, we have to get a common denominator. So we can't just do 19 over 6 minus 2. We have to get a 6 on the bottom. So this is 19 over 6 minus 12 over 6. That's where it comes from. Does that make sense? The question was, where does the 12 come from? 12 pi over 6. I talked about it being 2 pi, but in order to combine fractions, we have to get a common denominator. So if we take 2 pi and multiply by 6 over 6, we get 12 pi over 6. So then we could subtract them. Oh, yeah, negative root 3 goes to the left. So when you have a negative over a negative, that does turn positive. Thank you, LeBron. So positive root 3 over 3. All right, a couple more. Negative 495 that's a really big number. I don't really want to play with that. So we could use coterminal angles by adding 360 to that. So we have a negative number that if we add 360 to that, it's just 135. When you're adding with negatives, you subtract them if you have different signs, and you keep the sign of the bigger number. So negative 135 puts us right here. This would be 45 degrees. So we have 1, 1, and root 2. Remember, anytime you go left or down, that side is negative. And cosine would just be adjacent over hypotenuse, or negative root 2 over 2. And then the last one, this says inverse cotangent of 2/3. The way we talked about doing this is we could just draw the triangle from here. So if cosine is 2/3, what would the tangent be? Well, in order to figure out tangent, we could do opposite over adjacent, but we have to figure out that missing side. So 2 squared plus y squared equals 3 squared. 4 plus y squared is 9. Y squared is 5. And it looks like y would just be plus or minus root 5. So the tangent would be opposite over adjacent. All right, so that's a big part of the test. We have a few more to go over. This one is number 4 on the non-calculator section. It says find the cosine of negative pi over 12. It's pi over 6, 30. So pi over 6 divided by 2 is 15. So this is really just asking you, what's the cosine of negative 15 degrees? And we talked about a formula where we could just do 30 degrees minus 45 degrees. This is called the summer difference formula. And if you take a look at the formula sheet, the cosine of a difference is cosine of the first, cosine of the second, the opposite sign, and then sine of the first, sine of the second. Well, we have 30 degrees and 45, so those are just our special triangles. 1, 1, and root 2. 30 is 1, 2, and root 3. So plugging these in here, cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Plus sine of 30 is 1/2. Sine of 45 is root 2 over 2. And we get root 6 over 4 plus root 2 over 4. You could leave it like that if you want. Or you could write root 6 plus root 2 all over 4. I think there's 3 more left. Problem number 5. says if 2 cosine squared of theta plus cosine of theta is equal to 1, find theta from 0 to 2 pi. So this is just asking you to solve it, but don't add the period. So the way that we do these problems is we always start off by making it equal to 0, and we're going to have to make a substitution just like the last problem. We talked a lot about factoring. The way this factors is going to be 2y, we're going to have y, 1 and 1. This has to be positive, and this would be negative. I don't want to spend time going through factoring. We've done that a lot this semester and on the very first section. If we go to solve this, we get 2y minus 1 is 0. So y is 1/2. And y plus 1 is 0. So y is -1, or cosine is -1. Well, 1/2 looks familiar to me, and so does -1. -1 was a quadrantal angle, and cosine, if you remember, is the x value. So x is -1 right here at -1, 0, when theta was 180 degrees or pi radians. So 180 degrees is definitely an answer. Remember, cosine was x, sine was y, tangent was y over x. We had all those formulas. Cosine of 1/2, well, that's a positive answer. So we're going to have all students take calculus. We can't draw it here or here because cosine has to be positive. And 1/2, I remember that comes from our 30, 60, 90 triangles. Cosine of 1/2 would have to give us a 60-degree reference angle. So you have to remember your special triangles, you have to remember quadrantals, and it looks like 60 degrees is one answer. The other answer would be almost 300, well, almost 360, but 360 minus the 60 is 300 degrees. Those would be the answers. Problem number 6, it says find all the solutions to, let's see here, 4 sine squared of 2 theta minus 1 is equal to 0. This was in one of the last sections we did before we got to law of sines and law of cosines with inverse trig. So we want to try to get theta by itself. We could start by adding 1 to both sides and then dividing by 4. And we don't want to know what sine squared is. Obviously, we just want to get rid of that whole thing. So the next step would be to take the square root to give us sine of 2 theta is equal to a positive 1/2, or sine of 2 theta is equal to a negative 1/2. When you take the square root, you do get plus or minus. To get rid of sine, we could take inverse sine on both sides. And let's see what this gives us. 2 theta is equal to, well, if all students take calculus, sine is going to be positive in quadrants 1 and 2, and it'll be negative in quadrants 3 and 4. In order to get 1/2, I remember that comes from the 30, 60, 90 triangle. So this was 1, 2, and root 3. Sine of 30 degrees would give us 1/2. So it looks like we have a couple different answers here. Remember, we still have 2 theta is equal to these, right? So one answer is going to be 2 theta is equal to 30. And that's going to be plus the period here. Another answer is going to be 2 theta is equal to 150 plus the period. We're adding the period because the problem's asking us to find all solutions. Similarly, over here, 2 theta would equal 210 plus the period, and 2 theta would equal 330 plus period. Is everyone okay with where this is coming from? We had to take the inverse sine of 1/2. The inverse sine of 1/2 is 30, but we had to draw it in every quadrant where sine is positive and every quadrant where sine is negative. So to finish this, we just have to divide everything by 2. And let's see, we get theta is equal to 210 divided by 2 is 105 plus 180K. That's one answer. Another answer would be theta is equal to 330 divided by 2 is 175 or 165. 165 plus 180K. This one would give us theta is equal to 15 degrees plus 180K. And this one would be theta is equal to 75 degrees plus 180K. And there's a couple other problems to talk about too. So a couple others. This is problem number 7. Problem number 7 says the sine of x plus 3 pi over 4 plus the sine of x minus 3 pi over 4 is equal to 1. Which looks a lot like the sum and difference identities. So you're given these formulas, and you just have to be careful when you go to do this. So For sine, formula is we do the sine of the first times the cosine of the second. 3 pi over 4, 45 times 3 is 135. And then plus cosine of the first, sine of the second. And then we have to do this piece. So this would just be when you subtract with sine, it's sine of the first, cosine of the second, minus cosine of the first, sine of the second. We get this huge thing. So let's see. This term and this term look like they cancel. You have a positive cosine sine 135 and a negative. These two we can combine because they're like terms. This is 2 times the sine of x cosine of 135 is equal to 1. 135 gives us a reference angle of 45 degrees. Negative 1, 1 over 2. So the cosine of 135 would just be negative root 2 over 2. Really close to finishing this because this 2 and this 2 cancel. So negative root 2 times the sine of x is equal to 1. And we could just divide by negative root 2. So I've seen this before. This comes from a reference angle of 45 degrees. If all students take calculus, I'm going to draw 45 degrees right here to get a negative sign and a 45 degrees right here. These two angles would be our answer. The question is asking us just to solve from the interval from 0 to 2 pi, so we don't have to add the period. It looks like the answer is just going to be 180 plus 45. And the second answer is going to be 315 minus, or 360 minus 45 is 315. Those would be the two answers. There is one last problem that I wanted to go over with you. The last problem says to prove the identity that cosine of x divided by 1 plus sine of x is equal to secant of x minus tangent of x. You also had about 4 worksheets on this. Plenty of practice material in the supplemental folder. So let's go ahead and finish up with this. So which side looks more complicated, the left or the right? The left side looks more complicated. And taking a look at the right, remember we're not allowed to touch the right side, but secant is 1 over cosine. Tangent is sine over cosine. So we're not gonna like move anything around, but just from looking at the right side of the equation, I could see we have to get cosine in the denominator. Right now we have sine in the denominator. So there was a formula that we talked about where sine squared plus cosine squared equals 1. Bless you. Sine squared plus cosine squared is 1. So just from practicing these problems, the way we could get something with cosine is if we were to multiply the top and the bottom by 1 minus sine. What that'll give us on the bottom is 1 minus cosine squared, which is sine, or 1 minus sine squared, which is cosine squared, which is what we want. So let's see what happens. If we do this, we're going to have cosine of x times 1 minus sine of x divided by 1 minus sine times 1 plus sine. Distributing, we get cosine of x minus sine cosine. And on the bottom, if we distribute, we get 1 plus sine minus sine minus sine squared. These cancel. And remember what we said, we have to wind up with cosine on the bottom. So right now we have 1 minus sine squared. If we just subtract the sine squared using our property, Pythagorean identity, 1 minus sine squared is really the same thing as cosine squared. So we get cosine of x minus sine x cosine of x all over cosine squared of x. The way that we finish to get this to look like what we started with is we could just write it as separate fractions. So cosine of x over cosine squared of x is 1 over cosine, which is just secant. And then minus sine x cosine x divided by cosine squared. One of these cancels with one of these. And then sine of x over cosine of x is tangent of x. And that's exactly what we wanted.